All right, let's look at some examples of logistic differential equations in practice. So we have a population P of t of fish in a pond satisfies the logistics differential equation. dP over dt equals P times the quantity 4 minus P over 6,000, where T is measured in years and the initial population is 8,000 fish. What is the carrying capacity? Well, we want to get this into the general form of dP over dt is equal to Rp times 4, or let me restart that completely. Rp times 1 minus P over K. So I need to get this 4 factored out. So that can be rewritten as dP over dt is equal to 4P times 1 minus P over 24,000. Because if we divide 4 from both of these, it's going to be 4 times 6,000, giving 24,000. So what is the carrying capacity? Well, the carrying capacity is whatever under my P here. So K is equal to 24,000. Nice and easy. What is the equation PT that describes the population? We could plug everything in and work through this and solve it. But like I said before, the AP test generally doesn't expect you to do that. This kind of question probably wouldn't come up on the AP test. If it did, it would just be a lot of algebra working through it, solving that separation of variables, integration using partial fraction decomposition. But for the sake of this exercise, because we know the general solution to the logistic differential equation, PT equals P naught K e to the RT over K minus P naught plus P naught e to the RT, we can just plug things in. So P naught is the initial population of 8,000 fish. And then the K is 24,000 fish. 24,000, 8,000, yep. E to the, we found R was 4, so 4T over K minus P. K is our carrying capacity, so 24,000 minus 8,000 plus P naught, so that's another 8,000, e to the 4t. And then you can go through and algebraically clean that up a bit if you want, but that's the idea here. A second example, in a given forest, the carrying capacity for a population is 2,000 members. If the population has a growth rate of 3, what is the equation PT that describes the population of deer over time? Well, we don't know the initial population, but we can write the differential equation. dP over dt is going to equal R, which they said was 3, times P, times 1 minus P over K, which is 2,000. So what would be our final P of T? Well, it's going to equal the initial population, which they didn't give us, but we could fill it in later if they, if you found that information out, times 2,000 e to the 3t over the population K of 2,000 minus P naught plus P naught e to the 3t. And again, you can do some algebra. Well, actually, this doesn't have much algebra to clean up, but that's the solution there. Usually what you'll get questions with on the AP test is something from interpreting the graph, and the Khan Academy problems do a good job of showing those to you. We can also talk about them more in class if you had questions on them.